Yesterday we talked about points, lines, and planes, and how to name those points, lines, and planes. Today we're going to add a couple vocabulary terms on top of that, and then we are going to practice with that. So we're on page 2 in your pink notes packet. We're going to talk about space. Space is the infinite area in which points, lines, and planes can exist. And then these are the 2 new vocabulary words we're going to add. And actually, it's more like 4 vocabulary words, but only because one, we have the term, and then one of the vocabulary words is not that. So the first one we're going to look at is collinear and non-collinear. Collinear points are on the same line. So here in this picture, points A, B, and C are collinear. They're on the same line. And again, we're on page 2 in your pink notes packet, so back side of the front page. So that's our first new vocabulary term, is collinear, on the same line. Second new vocabulary term is non-collinear. What does that prefix of non mean? Not, correct. So these 3 points right here, D, B, and C are on the same line together, but D is not on that same line. So these are non-collinear. And then similar to linear or collinear and non-collinear, we have coplanar. These are points that are in the same plane together. So P, Q, and R are coplanar. And then we have non-coplanar. And I'm going to draw on this picture and add some more to it so that we can look at non-coplanar. Remind me of your name, dear. Got it. You said Amari? Right here? Okay. Do you remember what desk you're in? You're welcome. All right. So a plane, as we discussed yesterday, is a flat surface. So I have a representation of a plane right here. I have my green folder. This is going to represent what up here on the screen is this blue flat surface. So what I've drawn on here, P, Q, and R are all on this green folder. T is on this green folder also. But V is down here somewhere. So all of the dots that are on the blue flat surface are on here. V is not on the folder, it's down here. So that would be non-coplanar because it's not on the same flat surface as the other points. So these 3 right here would be a good example of non-coplanar. Right. So when we talked about how to name points, lines, and planes yesterday, to name a point, we use a single capital letter. And to be a point, it has to have a dot with it. If you see a capital letter without a dot, that is not a point. To name a line, we have 2 forms for how we can name lines. We can use a lowercase cursive letter to name a line, or we can use 2 points that are on that line. And to name a plane, we can use a capital cursive letter that's not a point, like the S right here. Or we can use 3 points on the plane that we can draw a triangle in between, but they all have to be on the same plane together. Let's look at examples 1 and 2, and we are going to practice naming some of these things. And we're going to practice it in a way that goes a little bit beyond the directions so that I help prepare you for the way the homework is going to ask for you to name things. So on number 1, first thing we want to do is name a line containing point Q. Well, here's point Q right here. Does Q have a dot with it? Yes. Are there any letters there by that line that don't have dots? C does not have a dot. Do you see how it is kind of looking a little cursive-y? They don't do a very good job making them look cursive, so sometimes we have to squint at them a little funny. But it is definitely a lowercase c, right? So we can name the line C. We have to write the word line next to it, and then we put the lowercase cursive letter after that. We can only do that if it does not have a dot and if it's lowercase. The other way that we can name a line is by picking out 2 points on this line, and it has to contain point Q. What are the other dots? What are the other points on this line right here? T and R, yes, thank you. What's your name, dear? Nathaniel Jones? Okay, do you remember what desk you're in?
No, I wasn't here yesterday.
You weren't here yesterday. All right, so let me tell you what desk you're in then. You are right here in desk 9. And then let me get you the papers that you're missing. All right, that's for starters. All right, this can go home and stay home. This is the syllabus for the class. And then this is what we're taking notes in. We're on page 2 on that right now. Do you need a writing utensil? All right. Okay, so we can call this line C. You said that T and R are also on this line. So when we name a line, I need just 2 of the dots that are on that line. So I could call this line QR. That by itself is not quite enough to say that it's a line. Does anybody remember from yesterday what that's missing? Yes. Yep, has to have the dash over the top with the arrows on either end. This right here means line. Without the dash and the arrows, it actually has a different meaning. And we'll talk more about that next week. But when you leave the dash off the top, you're saying, I went and measured this with a ruler, and I know how big it is. So when you leave the dash off the top, we're not talking about the line itself anymore. We're just talking about how big that line is. So kind of like the difference of somebody referring you to by your name versus somebody just calling you by your height. Does that make sense? Okay. We can also switch those 2 letters around. So this could be, instead of QR, it could be RQ. Now, when I do that, when I just switch the letters around, we say that that is not distinct. It's the same letters. Not distinct. There's nothing wrong with that, but there are some questions on the homework where they ask for you to name all of the distinct or different ways of naming a line. But what I want to point out here is on the answer key, when we go to grade homework on Tuesday, when your first homework assignment is due, If you write down QR on your homework, but when you look at my answer key, I have RQ, that's okay. You wrote the exact same thing as me. When you flip the letters around the opposite way, that does not matter at all. It's the same answer as mine. It's non-distinct. All right, so I could call this QR. I could also call this QR, or sorry, QT, not QR, QT. That still contains point Q. Or we could do TQ instead of QT. I see one other way of naming this line right here that uses just two of the dots on the line that is different from any of the other ways that I have written up above. Does anybody see what that would happen to be? TR. TR or RT. And were you here yesterday? No. Okay. I have you in desk. Desk 15, which is going to be this desk right here with the purple seat. All right, let me get you all the papers that you need, and then we will go on and do part B.
How do you spell not?
Not distinct.
Yeah.
DISTINCT. All right, this guy you can take and leave at home. Here's the syllabus for the class. And then we are on page 2 of the notes packet right now. You'll have to make sure to have that with you every day, okay? All right. One thing I want to point out very quickly before we move on to part B, I had some great questions about this last period, but somebody asked me, they said, well, does TR really work? Because doesn't it have to contain point Q? And that gives us a chance to talk about some differences in notation. So T and R are right here. If I want to talk about just the space in between T and R, not going past on either side, that would be a line segment. And the way I would talk about that would be TR with a dash and no arrows over the top. So that does not contain point Q. But because lines go on forever, this doesn't stop right here at R. It continues on, and it does contain point Q. One last thing that I wanted to point out is all of these up here across the top, these are all distinct. These are all distinct. They are different ways of naming the same line. All different names for the same line. Your homework will ask for distinct ways of naming a line or distinct ways of naming a plane. That means there has to be at least one letter different between the different names that you're giving. If it's the same 2 letters, just in a different order, that is not distinct. But as long as one letter changes, it is distinct. Does that make sense? Cool. All right, part B. A plane containing points S and T. Does anybody see a way that we could name this plane that would be the most simple way to name the plane with a capital cursive letter?
Oh, X.
Point X?
Oh, wait, never mind.
That's okay, you were looking at the bottom picture, but you were looking in the right spot. A, yes, plane A. And we know we can name it plane A because A is not a point. And how do we know that A is not a point? Yes, no dot next to A. If it has a dot next to it, I need 3 named dots to name the plane. If it has no dot next to it, I need 1 capital cursive letter. All right, so we can call this plane A, or I can pick out 3 of the points that are in this plane as long as I can draw a triangle in between them. Would I want to pick point V? No, it's up above the plane. It's not on my plane. I can't name the plane with a point that's not on it. So I don't want to use point V. So my choices are which points?
Point T, R, and Q.
T, R, Q. Any other points up there?
S.
S. So T, R, and Q, that's actually a great one. Let's talk about T, R, Q. Plane T, R, Q. That's actually not a good name for this plane, but I love talking about it right here, so I'm glad this got brought up. Because T, R, and Q, can I draw a triangle between T, R, and Q? Then I can't use it to name my plane. T, R, and Q are collinear. If the points are all on the same line together and I can't draw a triangle with them, then I can't use it to name my plane.
You want to write that down?
Yes, please. It's what we call a counterexample. It's an example on there that's like, make sure you don't do this, because it's a very easy pitfall to fall into. All right, so plane A would work. If I can't do T, R, and Q, can you give me 3 letters that are not all on the same line together that I could draw a triangle in between? STR. Plane STR. Or could I do RTS? Would that be okay? What's the difference between these two? Are any of the letters different? No, just the order of the letters. So does anybody remember what we would call that when all the letters are the same, but it's just a different order?
Not distinct.
Yes, not distinct. Does that mean there's a problem with it? No, just means your answer might look different than mine, but you didn't do anything wrong. Yours are in a different order than mine. What about, could I do SRQ? Yep, I could do plain SRQ. Does anybody see one more name that we could do using, I've got 4 points up here. I only want to pick 3 of them, and I want it to be distinct from what else I have up here. STQ, yes. We could do plain STQ. Looks just like this one, but it does have 1 letter difference, so it would be distinct. Nice work. All right, let's switch down to number 2 now. For number 2, part A, and for part B, we're going to look at this picture that's down here. For part A, we have kind of like a multiple choice or multiple response. We're going to pick out the names that work and cross out the names that don't to name this plane, and I'm looking at the blue flat space here. So could I call this plane CBA? No. What's wrong with that? Yeah, A and C are off the plane. There's another problem with it too. What do you notice about A, B, and C? They're all in the same line. I can't draw a triangle. So 2 of the points are not on my plane, and I can't draw a triangle with it. So it's got 2 things going against it. Nope. And we're going to say collinear. Let's look at the one right below it, DBE. Could we call this plane DBE? Why not? Can't draw a triangle, all on a line together. Those are also collinear. What about plane FBE? Yes. I can draw a triangle from F to B over to E, and it's all on the same flat surface. Nobody is above, nobody is below. So that one will work. Let's go right below that. Can we do XBF? Why not? Yes, I love it. X is not a point. X is the name of the plane. And we know it's not a point because how? Has no dot. X is not a point. All right, let's go to the last column. CFB. Can we do that one? No, why not? Yes, C is non-coplanar to F and B. What about plane X? Can we call this plane X? Yes. If on the test I ask you just give me a name for this plane, any name will do. You could call this plane X and move on. You could call this plane FBE. Could you call this plane FDB? Yes. Wonderful. Now we want to name a line that contains point E. Point E is over here. Do we have lowercase cursive letters like we did in the problem beforehand? So I can't call it something like line C this time. How many letters do we use when we name a line? 2 and only 2. How many points are on that line? 3. So I want to pick out just 2 of them, and any 2 will do. Can somebody give me 2 points on that line? BE is the first thing I heard. BE. Is that good enough? Yep, we need the line with the arrows over the top. That means I'm talking about the line itself, not how big the line is. Without the dash and the arrows over the top of it, that's the same as just saying like 5 inches. You're like, what? If you want to talk about the line, you have to put the dash with the arrows. All right, what's another name that I could give for this line? DB. I see one more distinct name that we could give to this line. I heard D, but then I didn't hear another letter. DE, yes. DE. So BE, DB, and DE would all be distinct names for the same line. Very nice work. Let's go to the bottom of the page and practice looking at some real-world objects and what these objects would be modeling, what geometric figure these objects are modeling. So the first one that we're going to look at here is the notebook. And when I want to know what geometric object is it modeling, I'm looking for a point, a line, or a plane. That notebook is a flat surface, right? So would that best model a point, a line, or a plane if it's a flat surface? A plane, yes. Now, instead of looking at the whole notebook, I want to look at just the edges of the notebook. A line, yes. How many lines are shown in the picture with orange? Close. Oh, yes, 4 total on the page. How many around the notebook? 3 around the notebook. Can you guys name those for me? JN is the first one that I heard. What else? JK is the top line. And KL, yes. KL would be the other line. What about the quarter right here? Point. What's the name of that point? M. That is point M. All right, so now for these last two, instead of looking for point, line, or plane, we're looking for one of those four new vocabulary terms that we learned: collinear, non-collinear, coplanar, and non-coplanar. Points N, L, and K. Here's N, here's L, and here's K. Are those collinear? No. Are they coplanar? Are they on the same flat surface? Yes, those are like the corners of the notebook. So they touch the edge of the notebook. Those are all on the same flat surface together. So those were considered to be coplanar. We're going to say those points are coplanar. But you said they're not all on a line together. How do we say not all on a line together in one word? Non-collinear, yes. Beautiful. All right, 3 new points now for this last bullet point here. P, Q, and R. Here's P, here's Q, and here's R. And it looks like those are being represented right along the edge of the pen, right? So would those be collinear or non-collinear? Collinear. These are collinear. Now, not a trick question, but kind of a trick question, so stop and think about it. Is the pen on the table in the picture? Is the table a flat surface? So the table would be an example of a plane, right? Are all 3 of those points on the same flat surface together? So would they be coplanar or non-coplanar? Coplanar. Beautiful. All right, let's flip the page and practice a little bit of Algebra 1, but we're going to do it geometry style. Do you guys remember plotting points and drawing lines in Algebra 1? All right, let's practice. You guys have had a summer off. We are going to draw and label a figure to represent this relationship. We have lines QR and ST that intersect at point U. The first point it tells us about is Q at -3, -2. Let's go plot that point. So -3 means left 3, -2 means down 2, so my point is right here. And in Algebra 1, I'm guessing that that's about where you guys stopped when you plotted your points. But how many points are we going to be drawing here at least? At least 4 points. So we're going to label our points so we know which line is which. That was point what? Point Q. So we're going to label this as point Q. In geometry, we always have to label our points. And then we have point R at 4, 1. So right 4, up 1. There's point R. And that is the name of one of our lines. One of our lines is line QR. So grab your straight edge now that you have those 2 points plotted, and we're going to draw a line that goes through those 2 points all the way across your graph. And then we have point S at 2, 3, right 2, up 3. There's point S. And point T at -1, -5, left 1, down 5 for point T. And then we want to draw a line through those 2 points also. So far, so good? All right, if I look at the directions here, that's the first bullet point. It says graph each point and draw line QR and line ST. So we did that. The next bullet point down says to do what?
Label the intersection as point U.
What do they mean by intersection?
Where the two lines meet.
Where the two lines meet. So where those two lines cross each other, I'm going to put a big dot, and we're going to label that as point U. When two lines meet, they make a dot, a point. All right, there's one more thing that they've asked me to do on this problem. It's this third bullet point down. And this one feels a little bit scary because they don't tell me exactly where to put point V. But that just means there's a lot of right answers here. It says graph, identify and graph a point V such that it is coplanar on the same flat surface with all of the labeled points, but is non-collinear to QR and ST. Well, this first part, making sure it's coplanar, that just means you have to draw it on the same piece of paper. You can't make it hang out in the air above your paper. You can't draw it on one of the pages below your paper. It has to be on this graph. Then it'll be coplanar because it's on the same flat surface. But we don't want it to be on the same line as Q, R, S, or T. So point V, I could put up here. Or I could put it over here. Or I could put it down here. Or I could squeeze it in over here. Could I put it here?
No.
What about here? As long as it's not on one of those lines, point V can go wherever you want it to. Let's do number 5. Same thing. I'm going to give you guys about a minute and a half to do number 5 on your own. And then we'll compare your answer with mine. All righty. So here is mine. Your line JK should look just like mine. Your line LM should look just like mine. The point where they cross each other should be point P, and then Q could be different than mine. As long as Q is not where, you're okay. As long as it's not on the lines. You can put Q wherever you want to. As long as Q is not on one of those two lines that you drew, you are good. All right. We're going to do one more problem, and then we're going to call it a week. Number 6. First thing we want to do on number 6 is how many planes appear in the figure. A plane is a flat surface, right? So I want you to imagine a simpler example before we get into this one. If you had a cereal box in front of you, how many flat surfaces does a cereal box have? 6. What are those 6 surfaces? We've got front and back, right? Side to side, top and bottom. So a cereal box has 6 planes. Have you guys ever seen boxes, especially for like fancy chocolates, that aren't the nice square or rectangle boxes? They're like all fancy triangle, pyramid type things. So that's what I'm seeing when I look at this shape right here. It's kind of a fancy pyramid. How many faces does that fancy pyramid have? How many flat surfaces? 5 flat surfaces. Are those the only flat surfaces in the picture, just those 5? No, there's also what? There's also the bottom. So how many planes are there total in the picture? 6. Beautiful. We have 6 planes. Let's go ahead and name those. What's a name for the big flat one on the bottom? P. We can call that plane P. All right. Now looking at this pyramid type shape, it's a little bit hard to see where the front and the back is. Do you guys notice that? It's like hard to get our perspective. Point G is in the back. Point A is at the top. Point C is on the left. this plane right here, if this object was sitting in front of me, this plane that I just highlighted would be kind of hidden in the back. How many points do I need to name that plane? 3. For a line, it's 2. For a plane, it's 3. And for a plane, can they all be in a line together? If I'm going to name it. No, I don't want my points all in a line together to name that. So ABC would not be a good name for this back piece. What could I use as a name for the back?
GAC.
A, C, and what was this guy back here? G. So I could use ACG. Plane ACG would be the back one. Let's move to the other back one. So A and G are still there, and this guy over here. So what could I name this plane? FGA or GFA. Plane FGA. All right, let's move now. This guy right here. He's kind of in the front, but still over on the right-hand side. What could we name him? EFA. Plane EFA. All right, let's move over to the left. What could I call this one? ABD. Plane ABD. Let's name the last plane, which is the one in the front, and then we'll call it a week. This one right here, what could we call this? ADE. Plane ADE. We will finish up this problem and then do pages 4, 5, and 6 on Monday. Homework is due on Tuesday. Homework is due on Tuesday.